Hi everyone. Today I'm just going to talk to you about some of the definitions that really point to what an acid or a base is in chemistry. There are a few ongoing definitions. Some of them are more simple than others, but you guys are going to come to know all of them and really identify who is the acid, who is the base, who is doing the proton donating, who's accepting protons. So all of these come into play when we're talking about acids and bases. So the Arrhenius definition is that acids and bases are defined by the products of their dissociations in aqueous solutions. So basically what that means is if something is an acid, when it dissociates in a solution, meaning it separates in a solution, it's going to release hydrogen ions. Okay, so just a high H+. But bases, on the other hand, when they separate in water, or they dissociate in water, what they're going to do is increase the hydroxide concentration. So that's OH minus 1. Okay, that's the Arrhenius definition. Bronsted-Lowry said, well, acids and bases are defined by the way they react with each other. So acids are going to be the proton donors in a reaction. They're going to give up their protons, and bases are going to be proton acceptors, meaning they're going to accept a proton. To go along with this, you also have something called conjugate acids and bases. And acids are proton donors in a reaction, and they will become a conjugate base after the reaction. And we're going to go through some examples together where we're identifying conjugate acids and conjugate bases. The bases are the proton donors, so after the reaction is over, they're going to become a conjugate acid. Okay, so for example, so how does one identify what is an acid, what is a base, and then what is the conjugate acid and what is the conjugate base? Well, there are a few steps. The first is to find the link between the similar compounds. So in the examples we're about to do, you'll see some that look similar. Determine if each reactant accepts or donates hydrogen to the partner. So once you identify who are the pairs, you're going to look at, is that guy accepting or donating protons? Okay, and then the last thing you have to do is just label them. Really, the hardest part is just noticing who accepts or who donates. So if you look at this first example, we have hydrofluoric acid and water yields a fluorine ion and hydronium. Hydronium is this H3O+. Okay, so you have to find who are the partners. Right away, I see hydrofluoric acid and fluorine. So these guys are alike. Okay, and then water and hydronium are also partners. They're also alike. So what you want to ask yourself now is, okay, what happened to this hydrofluoric acid? Did it accept a proton or did it donate a proton? So hydrofluoric acid went from HF to just F. So that means it donated a proton. So that's going to make HF the acid. And then if that's the acid, that means the fluorine ion is going to be the conjugate base. Okay, now water went from H2O to H3O. So that means it accepted a proton. Therefore, water is going to be the base, and that's going to make the hydronium the conjugate acid. Okay, so now that we have a more colorful view, I'm going to explain the next one to you. I have ammonia here. Ammonia is NH3, and its partner is this ammonium. Okay, so ammonia went from NH3 to NH4. That means it accepted a proton. Okay, so because it accepted a hydrogen, that makes it a base. and therefore the ammonium will be the conjugate acid. On the contrary, the water is H2O. It went from H2O to hydroxide. Now, that means it donated a proton. Okay, so it lost one of its hydrogens and now it's just OH. Okay, therefore, that makes it an acid and the hydroxide is the base. For the next example, you have acetate and hydrochloric acid yields acetic acid and chloride ion. Okay, so if you look here, this acetate, this is going to be its partner because they look alike. Okay, and you notice here we have a hydrogen, so it accepted a hydrogen. If something accepts a hydrogen or accepts a proton, that makes it a base. So this guy is our base, the acetate. When you identify your base, the partner becomes the conjugate acid. Okay, now here hydrochloric acid is HCl. It went from HCl to just Cl. So now that means it donated a hydrogen. It donated a proton. If you donate a proton, that makes you an acid. And then your partner is going to be the conjugate base. Okay, and the last one, we have nitrous acid. Okay, and then its partner is going to be this nitrite. And we also have water, and water's partner is going to be the hydronium. So we've identified who the partners are. Now I'm going to look at what's happening, okay? Well, HNO2 went from HNO2 to NO2. So that means it donated a hydrogen. If it donates a hydrogen, that's an acid. Okay, and then once you identify the acid, the partner becomes the conjugate base. With water, again, water went from H2O to H3O. That means it accepted a proton. If you accept a proton, you're a base. And then the partner becomes the conjugate acid. Okay, so this is just a nice clean view of what's happening. Again, we identified our partners. You look at who's similar. They'll usually have similar compounds or similar elements. And then you see on the reactant side, okay, who's losing a hydrogen and who's gaining a hydrogen. Whoever loses the hydrogen, that's the proton. Whoever loses the proton, they're donating it. That makes them the acid. Okay, and then whoever is accepting a hydrogen, accepting a proton, that is the base. Okay, on the product side of the reactant, whoever was the acid in the reactants, on the product side, their partner is going to be the conjugate base. And then whoever was the base on the reactant side, their partner is going to be the conjugate acid. So moving forward, I just want to go over some basic properties about acids and bases. We've talked about acids. They are producing hydrogen ions in solution. That's the Arrhenius definition. Their pH is going to be less than 7. So the pH scale, which we're going to talk about in the next video, the pH scale is from 0 to 14. Sometimes it's written as 1 to 14, but there are some pHs that can be less than 1. It's not very common, but it does happen. It does turn the litmus paper red. The feel of it kind of burns. If you ever have spilled hydrochloric acid on your hands in a lab, it does kind of have a burning sensation. They do taste rather sour, so lemon juice is a acid, and it does taste sour. So anything citrusy, vinegar, also another acid. So it has a sour taste to it, and it is corrosive. So it is able to break things down pretty efficiently. So acids are a little more dangerous. Bases are still dangerous too. For example, bleach is a base, and that is very reactive as well. So a lot of people think only acids are the dangerous ones, but bases do have some more cautious tendencies as well. For bases, the ion that they produce is hydroxide. Their pH is going to be above 7. So remember, 7 is neutral. Again, we're going to talk about that in the next video. Bases will turn litmus paper blue. They'll feel slippery to the touch. So a lot of shampoo is a base. So it does feel slippery when you put it on your hands in the shower. And they do taste bitter. If you've ever actually tasted the shampoo in the shower just by accident, like if it falls on your face, it should taste quite bitter. Okay? And it is what we call caustic, which means it's able to burn or corrode organic tissue.